by the end of class, you should be able to use the unit circle to evaluate trigonometric functions of any angle. So in class on Tuesday, we focused on very specific angles around the unit circle where we could get exact sine, cosine, tangent, cotangent, cosecant, secant values by using our special right triangles. Today we're going to look at their all different angles and trig values around the unit circle. So I will give you guys a second to get your notes out. If you're in person, you should be getting them passed out to you. Otherwise, if you are a remote learner, I'll give you a second to, if you printed them out, get the printout out. Or if you're pulling them up via Cami, pull them up via Cami. All right, so recall from yesterday that when we had angles graphed on a coordinate plane, we can find the sine of theta by doing y over r, cosecant of theta by doing r over y, cosine theta by doing x over r, secant of theta by doing r over x. Remember, that's a typo in the notes, so make sure you fix that again today. And tangent of theta by doing y over x, or cotangent of theta by doing x over y. And as the terminal side of the angle rotates, the values of x and y take on negative values. We can use this to determine which trig functions are positive in each quadrant. So as we saw on our unit circle, that in quadrant 1, both sine and cosine were positive. Both our x and our y coordinates are positive, which makes tangent positive because a positive divided by a positive is still a positive, which then makes all of the reciprocal identities, cosecant, secant, cotangent, also positive. So in quadrant 1, all 6 of our trig functions are positive. In quadrant 2, again, remember from our unit circle, our x coordinates, my computer decided to freeze. There we go. Our x coordinates are negative, but our y coordinates are positive. So in quadrant 2, sine is positive, which means cosecant is positive, again, like we saw in our unit circle, but cosine is negative, which makes secant negative, and tangent and cotangent will be negative because a positive divided by a negative is a negative. In quadrant 3, both x and y are negative, so sine and cosecant are negative, cosine and cosecant are negative. I said those in the wrong order, but they are all negative. Sine and cosecant are negative, secant and cosine are negative, but tangent and cotangent will be positive since a negative divided by a negative is a positive. And then finally, in quadrant 4, we have positive x values, negative y values, which means that sine and cosecant are negative, but cosine and secant are positive. And tangent and cotangent will be negative, again, because a negative divided by a positive will be negative. So we have an acronym to help us remember which trig functions are positive in each quadrant. So the acronym to help us remember are all students take calculus? Because in quadrant 1, all the trig values are positive. In quadrant 2, students stands for sine, so sine and cosecant are positive. Take, tangent, cotangent are positive. And calculus, cosine and secant are positive. So all students take calculus helps us remember which trig functions are positive in each quadrant. Any questions on that? All right, so let's actually come back to example 1. We're going to take a look at example 2. So find the coordinates of the point where the terminal side intersects the unit circle. This says to round each coordinate to the nearest hundredth, but we're actually going to find the exact value first and then round. I'm going to go to a new page really quickly. So this is a nice segue from what we did on Tuesday to kind of getting a little bit more comfortable with the unit circle. So as you might recall me saying, I don't bother to memorize the entire unit circle. I memorize quadrant 1, and then I use the all students take calculus acronym to help me remember if my function function value should be positive or negative. So for example, if we're looking at example 2, which is 7 pi over 6. So quadrant 1, filling that in really quickly, we have pi 30 degrees, which is pi over 6, which is the coordinate square root 3 over 2, 1/2. We have 45 degrees, which is pi over 4, which is the coordinate square root 2 over 2, square root 2 over 2. I'm going to have to move this. And then we have 60 degrees, which is pi over 3, which is the coordinates 1/2 square root 3 over 2. So 7 pi over 6 will refer back to pi over 6. But since 7 pi over 6 is in quadrant 3, if I were to graph the angle 7 pi over 6, that angle right there, I know that let me write these out real quick. I know that all students take calculus, so in quadrant 3, tangent and cotangent are positive, but everything else, sine, cosecant, cosine, secant, will be negative. So the sine of 7 pi over 6 is 1/2, or negative 1/2, because again, our sine values are the y values. So cosecant is -2, the reciprocal. Cosine of theta is negative square root 3 over 2. So secant of theta is -2 root 3 over 3. When we reciprocate that and rationalize. Tangent of theta is sine over cosine. So sine over cosine is 1/2 times 2 over the square root 3. So 1 over the square root 3. So when we rationalize, that's square root 3 over 3. And cotangent is square root 3, the reciprocal. And there we go. So that is how I use my unit circle. I don't memorize the entire 360 degrees, the entire 0 to 2 pi. I memorize quadrant 1, and then I use where sine and cosine are positive and negative to change the values. Because remember, the values are the same. It's just the positives and negatives that change based on the quadrant. Any questions on that? So going back to number 2 now, this was not asking for all 6 trig values. This was just asking for the coordinates. So since we are in graph 7 pi over 6, again, that refers back to pi over 6. But since we're in this quadrant, both x and y are negative. Go ahead, type those into your calculator and round to the nearest hundredth as well. So there was a question in the chat that said, how is memorizing quadrant 1 effective? What do you mean? Like, how do you apply it to everything else? I guess I still don't understand, because I just showed you how memorizing quadrant 1, we then applied it to an angle in quadrant 3, because 7 pi over 6 was quadrant 3. So we used the reference angle in quadrant 1, pi over 6, to get the answer to 7 pi over 6, which is actually in quadrant 3. Okay, if I didn't answer your question, if you can just word it differently or ask it differently, I'm sorry, I don't think I'm fully understanding. All right, so nearest hundredth, so we got negative 0.87. So there's the exact value, and there's the approximate value. Any questions over example number 2? All right, so if your angle is on the unit circle, we can obviously use the pre-filled in unit circle. But today we're going to look at angles that are not necessarily associated with the unit circle, or that are a perfect 30, 60, 45, or pi over 6, pi over 4, pi over 3 reference angle. So example 1 is going to be one of those examples. The point P, -5, -12, is on the terminal side of an angle. I spelled angle wrong. In standard position. Find the 6 trigonometric ratios. So what do I know? I know I have a point P, which has the coordinates -5, -12. And that's on the terminal side of my angle. So my angle is this angle here. Do I know that angle measure? No, absolutely not. Do I need to know that angle measure? No, absolutely not, because I know the coordinates of this point are -5, -12. So when we draw out the map from the origin going left 5 down 12, we have a right triangle. So I can go back to math 2, and to answer this question, I can do right triangle trigonometry. So theta is always the angle made with the x-axis. To get my hypotenuse, this is a triple. This is a 5, 12, 13 right triangle. If you do not know that Pythagorean triple by heart, you can do Pythagorean theorem to get the hypotenuse as well. So now we go back to math 2 and use our sine, cosine, tangent. Is sine is opposite over hypotenuse. Cosine is adjacent. Oops, over hypotenuse. Tangent is opposite over adjacent. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. These types of questions pop up on the ACT and the SAT fairly often. All right, any questions on example 1? Yes, so the question in the chat is the theta there because it's a reference angle? Absolutely, yep. I'm using the reference angle as my angle inside of my triangle because the reference angle and the angle itself will have the same trig ratios except for positives and negatives. But our positives and negatives are taken care of because of the angle being in quadrant 3. Yeah, no worries. Great question. Yeah. All right. Go ahead and complete the following 2 examples on your own. I will check in with you guys in about 2 minutes, see if you need some more time. Also, a common question that I usually get, your hypotenuse is always positive because if you're doing Pythagorean theorem, if you're squaring a negative, you always get a positive number. So your hypotenuse will always end up being positive. All right, would anybody like another minute before I show the answers to number 1 and number 2? No worries, 1 more minute. All right, take a look at number 1. I'll pause for a second to show number 2 in case you're still working. Any questions on number 1? And verifying our signs, since we are in quadrant 2, all students take calculus, sine and cosecant should be positive, but everything else should be negative. So a sine is positive, but cosine and tangent are negative. So we're good with positives and negatives. All right, and number 2. And same thing, using all students take calculus. In quadrant 3, tangent and cotangent are positive, everything else is negative. So notice cotangent's positive, but secant, cosecant are negative. So we at least know our signs are correct. S-I-G-N signs, not S-I-N-E signs. Any questions? So there's a question in the chat that said, can we make the triangle with the y-axis? And the answer is no. You have to make the triangle with the x-axis because our reference angle has to be the angle that's made with the x-axis. So if you're making your triangle with the y-axis, you're actually not using the correct reference angle. You're using the complement of the reference angle, which will change your sine and cosine values. So you have to make your triangle. That was a great question. You have to make your triangle with the x-axis. Anything else? All right. So let's do a few more examples. Find the coordinates of the point where the terminal side intersects the unit circle. Round each coordinate to the nearest hundredth. So 234 degrees. Let's graph that angle. So we have 180 degrees here, 270 degrees here. So 234 is, fairly in the middle between those two. A little bit closer to 270. And we want to find the coordinates of that point. So going back to our notes on the first page, remember that sine of theta is equal to y over r. So our y coordinate is equal to r sine of theta. And our x coordinate, cosine theta equals x over r. Our x coordinate, if we solve for x, is r cosine theta. But in this case, both are radii values as 1 because it's the unit circle. So my x coordinate is just cosine theta, and my y coordinate is sine theta. And again, this is review from our lesson on Tuesday, but I know it was still fresh, so it's good to repeat. So looking at this example here, since we're given that this is the unit circle, we know that our radius is 1, so our x coordinate is just cosine theta, or cosine of 234 degrees, and our y coordinate is sine of theta, so sine of 234 degrees. Now, this isn't on the unit circle, right? We've been doing this for, no, it's on the unit circle, but it's not referring back to a 30, 60, or 45 degree angle. So that's why it says to round to the nearest hundredth, because here we're not going to have an exact value. So number 3, get out your calculators. Make sure your calculators are in degrees. I'm going to pull up the calculator here. Oh, not degrees. Because I'm going to show you how to change them to radians in a second for a later example. All right, so make sure that your calculator is in degrees. So mode is right here, right to the right of the second button. So my calculator is in radians, so I have to change it to degrees. So cosine of 234 degrees is, there we go, negative 0.5877, round to the nearest hundredth, so that's 2 decimal places, so negative 0.59. And sine of theta, or sine of 234 degrees, is negative 0.809, so negative 0.81. And it is as simple as that. Negative 335 degrees. We have negative 90, negative 180, negative 270, so negative 335 degrees, roughly there, a little bit closer. Whoops. So since we're told to round to the nearest hundredth, we can use our calculators. Cosine of negative 335 degrees for our x coordinate, sine of negative 335 degrees for our y coordinate. We type that in. 0.91 and sine of negative 335 degrees, we have 0.42. Any questions on 3 or 4? And graphing the angle is not technically necessary for us to do the problem, but it is nice to see like our angles graph. Well, one, it's nice to practice graphing the angles. And two, it's nice to see, okay, our angle's in quadrant 3, so I should have a negative x and a negative y coordinate. My angle is in quadrant 1, so I should have a positive x and a positive y coordinate. It's always nice to make as many connections as you can. Any questions over 3 or 4 before we look at an angle in radians? All right, so number 5, 2.834 radians. So I know a full circle's 2 pi radians, which is about 6.28 radians. I know a half a circle is 1 pi radians, which is about 3.14 radians. So a quarter of a circle is a half of a pi, which if we do 3.14 divided by 2, or if you just do pi divided by 2, that's about 1.57 radians. So 2.834 radians will be roughly there. So our angle is in quadrant 2. So to find the coordinates, we have cosine of 2.834 radians, comma sine of 2.834 radians. But before we type that into our calculator, we have to make sure that our calculator is in radians, since our angle is in radians. So we go back to mode, which again is right here to the right of second, and change it to radians. Those of you that have the new calculators, you don't even have to go to mode. You have the option right from your home screen, right up top somewhere. It'll say like radians or degrees. So you're able to like change it right up top. Or you can go into mode to change it. I'm not 100% sure how that works. Or it might just be there to tell you right up top. But I know the new calculators, it's something in the home screen that actually says degrees radians. Older calculators, you have to go to mode to actually check to see if it's in degrees or radians. So my calculator is now in radians, so I have cosine of 2.834, which is negative 0.95. And then sine of 2.834, and we have 0.30. So again, double checking, I'm in quadrant 2, I should have a negative x and positive y coordinate, so that's good. And finally, number 6, actually, you know what, why don't you go ahead and do number 6 on your own? And I'll show the answer in 10 seconds. And there we go. Cosine of 6 pi over 7, sine of 6 pi over 7, which comes out to be negative 0.90, comma 0.43. 6 pi over 7 is almost a full pi, 1/7 short of a full pi, right? So we're in quadrant 2 there. All right, any questions over 5 or 6? So we're actually going to skip 7 due to time, and we'll come back to it at the end of class if we have time at the end of class. I want us to take a look at another type of problem. So number 8, find the cotangent of theta given the cosine of theta is 4/5 with the terminal side in quadrant 1. So this example here, we're given that the terminal side of my angle is in quadrant 1. So I'm going to draw an angle in quadrant 1. And I know that the cosine of my angle is 4/5, which means I know the adjacent is 4 and the hypotenuse is 5, because cosine of theta is equal to adjacent over hypotenuse. Or x over r if you want to think about it in terms of a circle as well. So we need to find the third side. This is a Pythagorean triple, a 3, 4, 5 right triangle. If you don't have that memorized, you can always do Pythagorean theorem to find that side. So cotangent of theta, we know is adjacent over opposite. So cotangent of theta is equal to 4 over 3. Problems like these, again, very common on the ACT and the SAT. Because you think I need to know what theta is to know what the cosine is. I need to know what theta is to know what the cotangent is, but you don't. You don't actually need to know what that angle is in order to answer these problems. All right, we'll do one more together. Number 9, find cosine theta given tangent of theta is 2/3 and the terminal side is in quadrant 3. So our terminal side is in quadrant 3. Using our reference angle, we draw our triangle. So tangent of theta, remember, is opposite over adjacent. So the side opposite is 2, and the side adjacent is 3. But since we're in quadrant 3, we actually have a -3 and a -2, because from my origin, I went left on the x-axis and down on the y-axis. So -x, -y. Now, this is not a triple, so I have to do Pythagorean theorem to find my hypotenuse. So -2 squared plus -3 squared equals my hypotenuse squared. That's 4 plus 9 equals c squared. So 13 equals c squared. So my hypotenuse is the square root of 13. So cosine of theta, which remember is adjacent over hypotenuse, is -3 over the square root of 13. But we have to rationalize. We can't have square root of 13 in the denominator of a fraction. So we multiply by square root of 13 over square root of 13. And we end up getting -3 root 13 all over 13. All right, any questions that we have over examples 9 and or 8? All right, go ahead and do 10, 11, 12, 13. Sorry, 10 and 11 on your own. We'll do 12 and 13 together, because 12 and 13 are just a little bit different. I'll check in about a minute and a half, see where you guys are at, and give you more time if needed. All right, would anybody like another minute to finish up 10 and or 11? Okay, 30 more seconds. All right, here's number 10. So we're given that the terminal side is in quadrant 4. Sine is opposite over hypotenuse. So we have the adjacent side being 4. So secant of theta, which is a hypotenuse over adjacent, gives us 5/4. Any questions on number 10? All right, and then number 11, we're given that the terminal side of the angle is in quadrant 2, and we're given that the cosine of theta is negative 1/2. So the cotangent of theta is negative square root 3 over 3. This is a 30, 60, 90 right triangle. It's also one of the ones that we're familiar with from Tuesday. So if you did not do Pythagorean theorem, you just knew that side was square root of 3, that's absolutely fine. Or you could have done Pythagorean theorem to get that side to be square root 3. Either way, and remember cotangent is adjacent over opposite, so we had to rationalize our answer here. Any questions over number 11? How come sides A and B aren't switched? Well, it doesn't matter what side is A and B, they just refer to the two values, but I think you mean like the adjacent and the opposite. Why aren't they switched? So cosine of theta is adjacent over hypotenuse. So again, our angle, our reference angle is always the angle made with the x-axis. So with respect to our angle, this is our adjacent side. This is our hypotenuse. This is our opposite. So that's why this is our adjacent side, is negative 1, because cosine is adjacent over hypotenuse. One comment that I do want to make before we look at the next type of example is that if you don't want to worry about positive negatives inside of your triangle, you don't have to. You can always use all students take calculus for your answer and say, since we're in quadrant 2, cotangent should be negative, so my answer should be negative. Or if we're looking at number 10, all students take calculus. Since we're in quadrant 4, secant should be positive because cosine and secant are the only positive ones in quadrant 4. So if you don't want to have to worry about filling in positives, negatives on your triangle, just make sure you double check. Since I'm in quadrant 3, tangent is the only one that's positive, so cosine better be negative. All right, number 12 and 13 are very similar, but just a little bit different in terms of information given. So for example number 12, we're given that the cosine of theta equals negative 1/2. Here's the problem though. I know all students take calculus. I know cosine is negative in quadrants 2 and 3. So cosine of theta is negative 1/2. So it cannot be in quadrant 1 because all of them are positive in quadrant 1. And my angle can't be in quadrant 4 because cosine's positive in quadrant 4. But now the question becomes, how do I know if my terminal side of my angle is in quadrant 2 or quadrant 3? In the last examples, it just told us, so we didn't have to think about it. But in this example here, it does not tell us. We have to use the other piece of information. Cosecant of theta is less than 0, meaning cosecant of theta is negative, meaning sine of theta is negative. So we're not in quadrant 2 because in quadrant 2, sine of theta is positive. So that means that our angle is in quadrant 3. Any questions on that? All right, once you do that, it's the exact same problem now as the last example. I know cosine is adjacent over hypotenuse. So my adjacent side is -1. My hypotenuse is 2. So my side opposite is square root 3. Again, because that's a 30, 60, 90 right triangle. So tangent of theta, which is opposite over adjacent, is negative square root 3. I'm sorry, positive square root 3. Because we're in quadrant 3, so tangent's positive. Cosecant of theta, which is hypotenuse over opposite, so that would be -2 over square root 3, which we would rationalize. To get -2 root 3 over 3. Questions on 12. All right, 13. We're given that secant of theta is -5/3. So we know that we're not in quadrant 1 because all of them are positive in quadrant 1. And we know that we're not in quadrant 4 because cosine is positive, therefore secant is positive in quadrant 4. So now the question is are we in quadrant 2 or are we in quadrant 3? So the other piece of information we were given is that tangent of theta is greater than 0, meaning tangent of theta is positive. So tangent of theta is positive in quadrant 3. So our angle is in quadrant 3. And now it's exactly again like the example above. Let's draw our triangle. Secant of theta is hypotenuse over adjacent. So our hypotenuse is 5 and our adjacent is -3. So this is a 3, 4, 5 right triangle. So our side opposite is -4. So sine of theta, which is opposite over hypotenuse, is -4/5. And cotangent of theta, which is opposite over adjacent, is +4/3. So there's a question in the chat that said, would it matter if you said -5 and +3? Yes, you would. Your hypotenuse is always positive. It's the x and the y values that will be negative or positive because it's a coordinate plane. So positive x goes right, negative x goes left. Positive y goes up, negative y goes down, but the hypotenuse is always positive because you're squaring your x and y to get it. And no. Yes, it would. Thank you, Naomi. Wouldn't cotangent be 3/4? Yes, cotangent is adjacent over opposite, which I think I said. I just then did not take the adjacent over the opposite. Very good. Thank you, Naomi, for catching that. Cotangent of theta is again adjacent over opposite, so -3 over -4, which is +3/4. Nice catch. Thank you. Anything else? All right, go ahead, do 14 and 15. I'll check in with you guys in 2 minutes, see where you're at. All right, would anybody like another minute to finish up these problems? Okay, I will show the answer to 14 in about 30 seconds, but continue to give you a little bit more time to work. All right, here's the answer to 14. Go ahead and check that. Let me know if you have any questions. All right, and then here's number 15. Go ahead, check that. And let me know if you have any questions. And I show how I figured it was in quadrant 3, of course. So we know tangent is positive, so that means it can't be in quadrant 2 or quadrant 4 because tangent is positive in quadrant 1 or quadrant 3. So the other thing we know is that sine of theta is negative. So it can't be in quadrant 1 because sine's positive in quadrant 1. So it has to be quadrant 3. Wouldn't cosecant be hypotenuse over opposite? Yes, it would. I switched those two answers. Thank you. Oh, I can't move him. Oh, no, sorry. Both the answers were the same. I over-erased. Cosecant of theta, I had sine of theta written down. Cosecant of theta is hypotenuse over opposite. So square root of 2 over negative 1, which is negative square root 2. And secant of theta is hypotenuse over adjacent. So square root of 2 over negative 1, which is negative square root of 2. So both answers should have been negative square root of 2. Nice catch. Thank you. Yeah, so the questions, can I show how I got square root 2? So a squared plus b squared equals c squared. 1 plus 1 is c squared, so 2 is c squared. So c is the square root of 2. Yeah, no problem. Anything else? All right, the last little bit is using the unit circle. So if you have your notes out from Tuesday, you have your unit circle out from Tuesday, I would have that out so you have it as a guide to reference. Meanwhile, I'm going to show you again how I use quadrant 1. I don't use the unit circle. Because keep in mind, you are going to have to be able to recreate the unit circle on your own, whether it's doing what I'm doing or whether it's give me a blank unit circle, I'm just going to fill this thing in. You're going to have to be able to recreate unit circle on your own. So I like to focus on quadrant 1. So again, that's 30 degrees, which is pi over 6 times 2 that for the small little space. There we go. Which has the coordinates square root 3 over 2, 1/2. And how I quickly remember that is it's big X, little y. 45 degrees, which is pi over 4, which has the coordinates square root of 2 over 2, square root 2 over 2. Samesies. And then 60 degrees, which is pi over 3, which has the coordinates 1/2 square root 3 over 2 because it's little x, big y. All right, so secant squared of 60 degrees. So we have 60 degrees here. Secant is the reciprocal of cosine. So since cosine is 1/2, secant is 2. So that's 2 squared minus tangent squared of 60. So tangent is sine over cosine. So square root of 3. And then we're squaring that. So we have 4 minus 3, which is 1. And if you needed to do the arithmetic for this, sine over cosine, that's okay. Do it. Just takes another couple seconds. No big deal. All right, questions on 16. All right, I'm actually going to have us do 17 together. So 2 pi over 3 is in quadrant 2, which means all students take calculus, signs positive. So looking at pi over 3, the reference angle, sine of pi over 3 is square root of 3 over 2, plus cosine of 7 pi over 6. 7 pi over 6 is in quadrant 3, where cosine is negative. So looking at pi over 6, the reference angle, cosine's square root 3 over 2, but since we're actually in quadrant 3, that will be negative square root 3 over 2. Plus tangent of 5 pi over 3. 5 pi over 3 is in quadrant 4. So in quadrant 4, tangent is negative. So looking at our reference angle, pi over 3, tangent is sine over cosine, which is, we did that work in the last example, square root of 3, but again, negative because we're in quadrant 4. So now we add square root 3 over 2 plus negative square root 3 over 2 is 0. So we're left with negative square root 3. All right, 1819. All right, here is 18. Take a second, look at your answer to 18. Let me know if you have any questions, and I'll still give you another minute to finish up 19. All right, here's 19. Go ahead, take a look at that. Any questions? Why is 3 halves negative? Negative square root of 3 over 2, because 5 pi over 6 is in quadrant 2. So in quadrant 2, cosine is negative. Or are you asking why is sine of 3 pi over 2 negative 1? Okay. Yep. Anything else? All right. Last couple problems are pretty much the same thing, but you're just verifying that the right side equals the left side. So looking at example 20, our left-hand side, I like to just kind of separate the two sides like that. Our left-hand side is the sine of pi over 3. So sine of pi over 3 is square root 3 over 2. And then the right-hand side, we have 2 times sine of pi over 6. So looking at pi over 6, sine of pi over 6 is 1/2, times the cosine of negative 11 pi over 6. So negative 11 pi over 6 is in quadrant 1, refers back to pi over 6. So cosine of pi over 6 is square root 3 over 2. And since negative 11 pi over 6, right, which is this angle here, is in quadrant 1, it'll be positive as well. So multiply, and we have 2 times 1/2 is 1, times the square root of 3 over 2 is the square root of 3 over 2. All right, I was hoping we'd have time for you guys to try one on your own. Time's gonna run really short. But go ahead, give 21 a try. If you kind of were working ahead, I'll show both answers to 21 and 22. If you were not working ahead, probably won't have time really to do either, but I want to make sure that the answers are shown just in case. So if you were working ahead, here is the answer to 21. And if you were working ahead, here's the answer to 20. Algebra is a bit messier for 22, lots of fractions there. All right. So if you have any questions, remember Thursdays after school are my after school office hours. So any of you guys are welcome to hop on and ask me any follow-up questions. I am here till 4:20, so those of you that are in person, you should have time to get on and catch the end of my office hours if you have any questions. Otherwise, have a great weekend, guys, and I will see you all on Monday.